This last bonus video reminds us three major things about bonding that carry over from one topic to the next, also are maybe the most commonly asked or most important things to do. First of all, bonding and bond energy connects to thermochemistry, thermodynamics, equilibrium, kinetics, and acid base, almost every other topic that we're going to do, reactions. So it's very important to remember that breaking bonds is an endothermic energy requiring process. We have to put energy in to get them apart. But when a bond is formed, we release energy because we are allowing things to attract to one another. The equation to know how much energy is absorbed or released is delta H, change in enthalpy for the process, is the bonds or attractions that have been broken minus the bond energy for those that are formed. This is an equation that isn't given, so we see it, practice it, and hear it a lot. Coulombs Law explains atomic structure. Coulombs Law explains periodic trends. Coulombs Law explains ionic, covalent, and metallic bonding. And Coulombs Law will also explain intermolecular forces and other attractions. So it's super important to think about, we know the attraction is based upon how big are the charges that are attracting the protons, the electrons, the cations, depending on the type of compound we're looking at, plus the distance between them. A lot of times distance in terms of bonding is defined by our atomic size. The small atoms can get much closer together, making a stronger bond and stronger force of attraction. The last thing is that there's so much focus on bonding about covalent. Ionic, it's governed by Coulomb's law, the size of the charges and the distance. Metallic, very similar. Covalent has more to it. We want to know, where are the electrons? How many are being shared? How long is the bond? How strong is the bond? What is the shape? What is the molecular polarity? Are these sigma or pi bonds? What types of orbitals? All of these things that I just said here. Which structure is best out of resonance or formal charge? If you are asked about any of those questions, they can only be properly and fully answered by drawing a Lewis structure. So make sure if you're given a compound and asked something about it involving any of these things, that you go through the process to draw the full Lewis structure. Just guessing is going to not give you confidence in the right answer. Sometimes it's multi-part, draw the Lewis structure, now do these things. But very often it jumps straight to the question, assuming you know to draw the Lewis structure. So for anything about any of that, any more advanced question related to covalent, start with a Lewis structure.